Well, hi there, and welcome Math 212 students. We are looking at section 9.3. We're going to be discussing surface area and volume today. So, saying that again, here we go. Common Core standards tell me that volume and finding the volume of rectangular prisms is introduced in the 5th grade. 6th grade, we're going to be looking at surface area and nets. And in 8th grade, we're going to be looking at volume of cones, cylinders, and spheres, all with pies. All right, we can think of surface area as the area that we need to cover the faces. We're going to cover them with carpet or with paint, something of that sort. Volume is what we need if we're going to put in that three-dimensional space. A lot of times we think of that as liquid that is contained within an object. Could be amount of cereal in there. That's sold by volume. All right. The Sweet Sugar Cube Company wants to redesign their boxes. And they have got some little sugar cubes. They've got, whoa, I did that again. Okay, I think I got it now where I'm on a pen. Let's see, I want to make sure that I have it was red, but now it changed. Oh, we're going to make it blue. So we've got boxes. Contained within those boxes are a bunch of sugar cubes. So we've got some little sugar cubes in our little boxes. And they're all going to stack on top of each other. So we can fit a whole bunch of sugar cubes in a box. Now I need to know how much cardboard I'm going to need for the package. So that's going to be the surface area that's going to be covered. How many sugar cubes are going to go in? That's going to be our volume because that's going to be something that's contained within. If we're talking about surface area, it's nice if we have a net. We draw the net and then the surface area is really easy because we look at our different shapes. So let me see, this is a 12. This is my 4. This is a 6. This is a 6. And this is a 4, 12. And let's see, that looks like if that's a 6, this is a 4 here, and that's a 6. So let's figure up the surface area of each of these different rectangles. So this is going to be a 24. This is going to be a 72. This is a 4 times 12. That's a 48. This is a 24. This is a 72. And this is a 4 by 12. So that's a 48. If you'll notice, I have 2 of these 48s. I have 2 24s. And I have 2 72s. That's because we have a top and bottom to each. So you're going to find formulas for these, but I just kind of like to do it with the nets and then calculate the surface area of each, but you are going to see formulas. Notice that you could say that I had 2 24s, 2 72s, and 2 48s. And then you would just add up all of those surface areas, and that would get your total surface area. Now, this drawing is a little hard to look at, but if you'll notice that it is 4, be nicer if they did like this. It's 4 different shapes with their nets. So if I wanted to calculate the surface area of this guy, just use the little rectangles, length times width. If I wanted to calculate the surface area of this one, calculate the surface area of each of those rectangles, then I would have to calculate the surface area of those 2 guys. Calculate surface area of the 2 triangles, and then my rectangles. Notice with the net and having that, it's so much easier. A cylinder. Now they carry on about this cylinder, but if I'm going to cover it with something, notice that I have 2 circles. I have a top circle and I have a bottom circle. So surface area is pi r squared. So I'd actually have 2 of those. But now what about this shape that goes around here? If you will just think about a soup label, and if you were to cut that label straight down where the seam is, and then open it up, what you would have would be, and here they're saying, a rectangle. Yes, we know that. So the lateral face is a rectangle. So what we have is, and they go through this, they show me that lateral face. What we have are two circles of pi r squared, pi r squared. Then we have a rectangle. Now this distance here happens to be the distance around that circle. So we're going to call that circumference. So that distance is pi times the diameter from here to here. And this distance is just going to be the height of that can. So if I want the surface area, I'm going to have two of those circles, a top one and a bottom one. This is this pi times, well, they don't say pi times diameter, they do 2 pi r, same thing. So this is also known as pi times diameter, but that would be length times the width. And then we would just add those all up. Volume is going to be how much we fill an object. Here with perimeter and my surface area, it's how much you cover or how much you go around something. So how are we going to fill this, and how is it that that is measured? Volume for a box or some sort of three-dimensional rectangular prism, volume is length times width times height. And with our elementary school students, there are many different computer software simulations that you can go to where they can count those little boxes. And there are also nice little manipulatives that you can buy for your classroom where they can count those boxes. So if they were to say 4 times 3 times 2, so 4 times 3 times 2, and that would be centimeter, 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 that would be 24 centimeters cubed. Sometimes you would say that would be 24 cubic centimeters. That's another way to write 24 cc. It's another way that you will see that written. And if they were to count the number of little boxes, they would find that there were 24 of them. So for our prisms and cylinders, you can just find the area of your base and then multiply it by your height, and you will get the volume. So you'll notice I got a little picture here where we get to look at our bases. You just find the area of each of those bases, and we have formulas for those, and just multiply it by the height. That is super cool, super easy. So let's do one. So in order to find the volume for a cylinder, I have to find, as we said, I need to find the area of the base. So area of my base, that is pi r squared. So that would be pi, so 3.14 times 7 squared. We'll get that answer. And then the volume is going to be, let me punch my calculator. Okay, I went and punched it, and that's what I got. The volume is going to be the area of that base, 153.86 centimeters squared times the height. So that would be times 10 centimeters. Oh, I like that one. The volume of that cylinder is 1538.6 centimeters cubed. So that's the answer to my A part. Let's do this B part. So I need the area of my base. Area is 1/2 base times height. That's 1/2. Base is 10 centimeters times 10 centimeters for that. So that'd be 1/2 of 100. I can do that one in my head. 50 centimeters squared. The volume of that would be the 50 centimeters squared times the height of that, and that would be 25 centimeters. And then that is going to be, let's see, 1250 centimeters cubed. Beautiful. All right, we're going to illustrate the formula for a pyramid by using a cube. So what they want you to visualize is that no matter what pyramid you make, if you were to make 3 of them, they would fit inside a cube. Therefore, the volume of a pyramid is 1/3 base times height. So they just did that just so that you could figure out where the volume formula came from. And that's important, especially when you're teaching the young students. You're going to want to show them exactly where that comes from. You might find videos, you might find manipulatives, something of that sort to help them figure out where this comes from. So let's look at that again. The volume of this pyramid is going to be 1/3 base times the height, because what they're saying is no matter which one of these you make, it takes 3 of them to fill a cube. That would be a great manipulative for us to look at if we could. All right. For a cone, similarly, you would want to show them it would take 3 cones to fill that same cube or cylinder, either one. Yeah, you probably say cylinder. That way you could show that. Notice how because of the circles on the top and the bottom, 1/3 base times height still. Volume of a sphere. Volume of a sphere is 4/3 pi r cubed. That formula is easiest to utilize if you have a little bit of calculus. It's really nice. But so we won't go into that one, but there is the volume of a sphere. The volumes of irregularly shaped objects, there are many different experiments that you can find, worksheets on the internet. Students really like doing this. It's something where you could reinforce your formulas as well. It was one of the experiments that I did in physical science, and the kids all really liked it. You can start with your 50 cc's of water. Remember, a cc is a cubic centimeter. And I have 10 of those cubic centimeters. If you count your little blocks, they're saying that each of these blocks is a centimeter cubed. If I drop them in the water, it raises the water, and this is determining volume by, it's called displacement method. So if you want to find one of these experiments, just look up displacement experiment. That's usually what I would look up as a physical science teacher. I would look up displacement experiment, and then I would find all kinds of different experiments in PDF form that I could print off the web, and then my students would do them, and they'd really have a good time with this because it's always fun to play with a little bit of water. So if you'll notice, so we have 50 cc's of water right here. Woo! 50 cc's of water. Once I drop this in, it goes up 10 cc's or cubic centimeters, meaning that this guy right here, his volume was 10 cubic centimeters. Once you do that with an object that they could count, that they knew the volume of, then what I would have them do is do rocks. They could do little figurines, whatever, but they could calculate the volume of this little doll or this little army man, whatever it was you're going to put in a graduated cylinder. So let's look at this one. This one is, let's see, 1, 2, 3. So this is 3.24, 3.4 cc's before I drop in my little man. And then it goes up. So I'm right to there. Yep. So I'm going to goes up 1 whole 1 and then 2, 4, 6. So it is 1.6 centimeters cubed, the volume of my little man. You can do your subtraction if you want. You can say 5 minus 3.4, and then that gets you the 1.6. I'm a little lazier than that, and I just counted. But either way, you still get 1.6 centimeters cubed for your volume. And this is just a lot of fun, and you get to do little experiments with volume. Anytime you can bring in manipulatives and do some sort of little experiments, you do not have to create your own. You can find them on the web, and they're so much fun. You teach your students something, and then you go and find some sort of experiment that they could do the next day. All right, and that concludes 9.3. So if you guys have any questions, you be sure and send me an email. Bye now.